Live from New York, it's Ask an Engineer.
Hey everybody, welcome to Ask Engineer. This is the best 1 hour live show in electronics in the entire known universe. It's me, Lady Ada, with me, Mr. Lady Ada, here at the Adafruit factory. We even have a new green screen friend we're going to show off a little bit.
Yeah, I'll talk about it in a bit.
We got a lot of stuff going on. We got new products, videos, tutorials, lots of tutorials actually, updates, it's not out yet, and more. Mr. Lady Ada, why don't you tell them what's on tonight's show?
Great, glad you asked. On tonight's show, the code is NeoSlider, 10% off in the individual store, all the way up until, heck, let's do midnight. NeoSlider is the code, 10% off anything we have in stock. Get it while you can. We have a bunch of live shows. We'll be talking about that, as well as our show and tell and more. We got time travel, look around the world of makers, hackers, artists, and engineers, news, and more. Some main New York City factory footage. We are a USA 100% woman-owned manufacturing facility that does open source hardware in New York City, and you get to see what it's like here through our lens every single week. We're going to show some of that. 3D printing, got a couple great videos from Don Pedro. We got everybody's favorite segment, Ion MPI, brought to you by DigiKey and Adafruit. We got some new products. We got some top secret. We're going to answer your questions. We do that over on Discord, adafruit.it/Discord, where you can join all 31,000 of us. We'll answer your questions throughout the show, at the end of the show, and even when we're not around, a bunch of people are around, you can hang out there. It's 24/7 hackerspace that you can feel safe at. All that and more on, you guessed it, Ask an Engineer. Okay, Lady Ada, well, let's pay some bills real fast.
Sure.
Or try to. NeoSlider's a code. When people put things in their cart, they get free stuff. What do they get?
$99 or more, you get a free permaproto half-size breadboard. It's great for making your projects permanent. It's the same size as the half-size breadboard, but with nice gold traces. $149 or more, you get a free Stemma QT breakout board. We have about 20 different options. Make an account, and we'll send you a different one each time. $199 or more, you get free UPS ground shipping in the continental United States. And $299 or more, you get a free Circuit Playground Bluefruit. We're out of Circuit Playground Expresses, but we are making more. We just have to wait for some chips to show up in case you didn't know about this chip shortage. But we do have some Circuit Playground Bluefruits in stock, and so we figured let's do the giveaway for a little upgrade, have some BLE action, and you can use it with PyLeap, which we'll talk about later on in the show. Very exciting.
Okay, and then just some news. So we've been, it's been a terrible last 18 months. And we're slowly starting to recover. Our team's doing good. Everyone's vaccinated. We're doing lots of stuff here at Adafruit to continue to just restart everything that was on hold. So one of the things is we wanted to up our game for these live shows and more. And so that's just a green screen. It's not going to stay there. I'm just moving some stuff around. We had a completely independent Adafruit at our apartment, and I've just been living in shipping supplies and all sorts of stuff because I would do a day shift or a night shift here and then continue to work at home. Same thing with Lady Ada, and so it was just basically like a command center forever. So I'm trying to move stuff around and more. And so one of the ideas is we'll be able to do more kind of live, interesting things with our puppets and more. So this is an example of a green screen, and that's some footage I shot. We use this for our AdaBox unboxing. There's a cool park called Little Island, and there's this really neat thing, and I had a black and white camera, and I took a photo of that and some videos, and we used it as the footage in there. But I'll be able to do neat things like live during the show, and you can see this is a, here I am saying, look at me, I'm gonna travel. So we thought that would be fun, and as we do this, I'm gonna show my work, and I'm gonna show all the things we do. So look forward to some exciting live action things here on the Adafruit shows. Okay, so we do a live series of shows. We just did show and tell. Thank you so much, JP, for hosting it this week. For the show and tell that JP hosted this week, I only got to see a little bit of it, but we had some all-stars. We had Jorvin, there was Jen Foxbot from Microsoft and more, so please check it out. I'm gonna watch it as soon as I get finished with the show. On Sundays, we do Desk of Lady Ada. Lady Ada, what did you show this week?
This week, I showed off the new ESP32 S2 Feather with TFT. So we got the ESP32 S2 normal Feather out, and also showed off some ESP32 S3 stuff. We actually have some dev boards in this week, so it was a little bit of a preview of what we had for the new products. But lots of cool stuff coming out from Espressif. They're shipping silicon.
Yeah. Then we do the Great Search, and that's brought to you by DigiKey and Adafruit. You find all the things that people are looking for, and it's getting harder nowadays. So what did you show in the Great Search this week?
Well, this week we actually showed off a cool post from Pololu. They talked about how they actually had some problem getting some MOSFETs, like silicon shortage. You know, a lot of people talk about microcontrollers and microcomputers and RAM and other kind of big silicon chips, but even the small silicon, like jelly bean FETs, are affected. And so actually I got notice today that one of the N-channel FETs that we're using for the prop maker Featherwing is like back ordered for 6 months, and it's just like an N-channel MOSFET, and not a very exciting part. But I did want to make something that get a replacement that was in stock that had the same specs, and so I showed how I found the alternative. I found a couple different alternatives, so you know, hopefully that's helpful for people as they are changing out their bill of materials. That's happening a lot these days.
Okay, great. JP's product pick of the week was this week. Little bit of a programming note. JP will be off next week for the product pick and also for workshop. I'll talk about some of the other shows. It's a holiday week, and I guess I'll talk about our schedule next week as well. But let's take a look at the product pick video of the week this week. Take it away, JP.
It is the latching mini relay Featherwing. We have a 24-volt power source that powers a ring light. The power comes from essentially the wall transformer to the Featherwing, and then when the Featherwing is closed, it will send that power along and over to the device. If I press A, that closes the relay, and you can see the big glow on my face, and then I can press a different button here to change that state. And like I said, if we put this into the latched closed position, it is going to stay there even if I kill power to this whole little setup. So I'm going to yank the power going to my feather. That means that this is not energized. It's not staying closed by virtue of a magnetic coil. It's staying closed because it has this little internal mechanism, a mechanical switch. It is the latching mini relay Featherwing.
And on Thursdays, JP does JP's workshop. This week, you can expect one next week. It is Thanksgiving, so we will not be having JP's workshop. CircuitPython Parsec is part of JP's show. We're going to play the latest one, but don't forget, next week, you're not going to see one, but you'll see it the week after.
What I want to show today for the CircuitPython Parsec is a really simple command that you can use to check how much memory is being used on your board when you are doing things, when you're importing things, when you're importing libraries, when you're using big files. How much memory have you got left? This is a really simple command you can use. It comes from the garbage collector library. And here's how you can use it in real time. So what I'm going to do is go into the REPL for this Pico that I have sitting right here. And now I'm going to just go and hit Control-C, which brings me directly to the REPL after going into screen. And I'm going to import GC, which is the garbage collector. Now, the garbage collector has a bunch of different things you can do with it, but what I'm going to use is this mem-free. So if I do a let's say print GC mem-free, it will tell me I have about 210K. If I then import a library, so I'm going to import another library. Let's do import USB HID library. Then I can run this print command again, or just GC mem-free will work. And you'll see now my available memory has decreased because we've added another library in. So as you can see by the code I have up above, you can sprinkle this through some code while you're debugging it and working on it, so you can have it do things, maybe bring in a library, check the available memory, and use it as a way of figuring out where you're running out of space in case that's something that's happening to you. And so that's how you can use the garbage collector to check the available memory on your board inside of CircuitPython. And that is your CircuitPython Parsec.
Okay, on Friday we have Deep Dive with Scott. That's at 2 p.m. Pacific, 5 p.m. Eastern. And Scott will be exploring all sorts of CircuitPython things. But next week, it's Friday, it's holiday. So Scott will be off, so it'll return next week, but there is one this week. Time travel. We got a bunch of news we're going to do this week, Lady Ada. So first up, PDFs are exciting, if you're us. They're also, and I'm just going to read Tyler's post. So we did a massive update to the PDF system on Learn. It's one of the features that everyone wants, teachers in particular, like, this is the best thing because I need PDFs. And read the blog post on our site. I'm just going to do a little bit of, anyone who spends a lot of time working with the Adobe PDF format knows how painful the process can be. This is doubly true when trying to automatically convert documents and web pages to PDFs. The PDF generator for the Adafruit learning system for years has been unreliable and buggy. We have kept the PDF generator from breaking with lots of duct tape and bubble gum, but we eventually ran out of bubble gum. So we decided to do a complete overhaul of the PDF generator. So if you look at it, the layout is improved. Everything about it looks better. The code, it is a work of art. If you're into documents and documentation, do check it out. Really proud of it, and good work, Justin and team. We're doing a favor for our friends at Microsoft. I would not do this if I didn't know for sure that these are good people and they're not going to mess with your email address or anything. What they're doing is a maker, entrepreneur, and small business survey. You can follow the short URL. I'm going to show it in a second. But they just want to get input, and there's a bunch of Adafruit stuff mentioned as well. So you can go to aka.ms/maker entrepreneur survey and fill it out and tell them what they use and tell them what you want. There's a bunch of interested people at Microsoft, and out of all the companies that we work with, Microsoft is up there in the tops. We work with a lot of people at GitHub and a lot of people at Microsoft, and they're good peeps. Next up. So a little reminder, we've switched to editions for, see, one of the cool things, I'm going to be able to have like seasons that show up. We watched some of those Next Generation episodes where like they would find a portal to another thing. So maybe we'll have like it's snowing and stuff like that. Yeah. But anyways, go to adabox.com. We moved to the winter edition. So if you want to get the winter edition, sign up now. You'll get notified when we're opening up more subscriptions, and it'll ship out early next year.
It will not ship before Christmas.
No, it will not.
Nothing, by the way, is shipping before Christmas. So
Nothing.
just be aware.
Yeah. Next up, let's do a little bit of Collin's Lab notes. I'm going to play 3 quick videos back to back, and then I'll see you on the other side.
If you've only worked with through-hole components, storing surface mount parts may seem like a challenge. Regular storage drawers won't cut it. You'll want something more compact that closes securely. For a small collection of SMD parts, you might get away with using envelopes or a sectioned pill box. For a sturdier, more specialized solution, there are these modular snap boxes which pop open with a press, come in a variety of sizes, and can be connected for a customized configuration. If you have a large surface mount inventory, the Boxall gives you 144 individual pop-open compartments in a clamshell case. And that's a lot of spots. And if you need an instant inventory of surface mount parts, you can pick up a variety of resistors and capacitors of a particular size in tidy ring binder format. You can't beat pre-organized. Bare stranded wire is not terribly durable, and frequently changing screw or spring terminal connections is a great reminder of that. When you need to connect and reconnect often, but soldering on the appropriate jack and plug hardware isn't an option, there is the oft overlooked wire ferrule. Wire ferrules are simple crimp connectors that gather and strengthen exposed wire ends. They're a bit like the aglets found on the end of shoelaces. They're available in a wide variety of sizes, and include a plastic collar for strain relief. Just strip the end of the wire, insert it into the ferrule, and use a crimping tool to secure it in place. Suddenly, my speaker connections are far less chaotic. Another curious feature you'll find recurring on PCBs is this little circle. It's called a fiducial, and it's a registration mark, a bit like those used to align ink layers in color printing. It's a target or reference point used by visual sensors on pick-and-place machines to properly place the board's components. A good PCB fiducial has no nearby circuit traces. It consists of a central copper disc surrounded by the exposed matte surface of the PCB substrate, and finally the board's solder mask. Multiple fiducials are better than one. You'll often find them located at opposite corners of a board in order to improve accuracy. It's like a little eye, just lying there, and staring back at you.
Okay, and a little bit of announcement. Collin's Lab Notes will be taking a break from now until January, where we hope to have a bunch of new Collin content, so stay tuned for that. Python on hardware news. Lady Ada, it is time.
Yes. Blinka, blinka.
There is so much stuff. We were just talking about how many boards are there on circuitpython.org/downloads.
I'm really glad you asked. There's 248.
So when there's 250, what's the 250th anniversary color or jewel?
Platinum? I don't know. I mean,
'Cause
most
isn't-
people don't live that long, so I don't think there's like a gift.
Wow.
But we can make some cool graphics.
Some of us do. Okay, so let's go over the newsletter. CircuitPython 7.10 beta is available. Check out all the things and more. Is there anything in particular that you want to?
People who are interested in async I/O and concurrency will, well, first off, check the notes. We added C3 support. There's a couple things that made it right after 7.0. But for the most part, we're caught up to 1.17 on MicroPython. We have a bunch of graphics and camera stuff that Jepler's added, and async I/O support's coming.
Okay. Make Magazine is now on the Internet Archive, but you can check it out. And by check it out, you reserve one and you get to use it, and then you turn it back in. In particular, if you want to check out the issue that you were on, the Rise of the Python issue, and then German was on the cover of Make recently. So there's some really good ones. Check it out. We have links to that and more. There was the PyCast over on Tom's Hardware. Scott talked about booting CircuitPython on the Raspberry Pi. We have the updates with Visual Studio. This one I sent over to Ann to put in. This is an open source interface prototyping thing. For the folks who are like, you're working on an interface together on something. This is an open source collaborative thing. It's in beta right now. It's called PenPot. A lot of people are designing mobile interfaces with our stuff too. So it's like, well, this is kind of a cool thing. So check it out. Open source. And then we have our usual long list of things that you'll be able to make, create, and do with Python on hardware. It's unending.
Actually, technically, it does end.
Look, I'm just going to scroll and scroll. I'm now burrowing a hole in this trackpad.
Yeah.
It's just going on forever and ever and ever. So my highlight of the week this week was a tweet that I thought was kind of interesting. So someone was like, hey, do you have any suggestions for sources for a 12-year-old to get interested in introducing coding? And this person, Thomas, I think, said it best. Just keep it fun. Circuit Playground was developed with teenagers in mind. Adafruit has tons of tutorials and vlogs maybe start with, and they put the product there. Also, if your niece is looking for a role model, the whole company was built by a pink-haired lady in Manhattan. So
It's true.
one of the things, No Start
This is not a
Express-
green screen.
Yeah. If I got a pink screen, it would look like, you wouldn't be there.
That'd be cool.
Sometimes on Desk of Lady Ada, when there's something on your screen that's green, it shows through. It's kind of cool. I emailed the No Starch folks because I'm like, hey, y'all might want to consider doing a CircuitPython book for kids. So we'll see. I keep emailing them these examples, so we'll see if they do it. But I thought that was neat because sometimes people say the thing that you're thinking even better than you could. And I thought that was cool. And then next up, Trevor is working on PyLeap. I'm going to put the links in the chat right now because you'll be able to get on this demo and this beta and more. So while this video is playing, I'm going to put those links in, and I think our team is going to as well. You can join this right now. Here we go.
Hey, this is Trevor, and I'm here to show you our new PyLeap beta. PyLeap basically takes example code from the Adafruit Learn system, and you're able to transfer that same example code to your Bluetooth device. Let's see that in action. So first I'm going to put this into pairing mode. Make sure it's right. There we go. All right. Okay. Now we're going to run our first example project. Send over some rainbows to our CircuitPython Bluefruit. Bam, there we go. Let's send over a blinking example. There we go. Let's try.
Okay. I think I had that on loop. So I put the links in the chat. What I'm going to also do is put them in the other chats. And then let's see if there's any other place. If anyone could help anyone who still needs it, please put them in all the chats. I think I got to all of them. So you could be on the beta, and then you can try this out on your own. And with that is Python on Hardware News this week.
Yay, Blinka!
Not only is this company run by this pink-haired lady in Manhattan, but we're an open source hardware company. The Open Hardware Summit is this year. They asked for sponsors. I'm fast on the PayPal, so actually I think Stella did this one. So we donated so we could be a sponsor of the summit. As soon as they give us the confirmation, we'll put a blog post up and more. And it's in April. I don't know if it's virtual or if it's in person yet. I got to check. But we're in New York, so I assume it's going to be in New York. So it doesn't matter either way for us. But if it's in person, I'm hoping to see some of y'all and more. And if you're considering supporting OSHWA and open source hardware, this is a way to do it. Other things, this was in the news, and I just thought it was interesting. So there's some legislation and more about like right to repair. Mm-hmm. So Apple announced that they're going to start sending people stuff to fix their iPhones at home. That's a big deal.
Yeah, like battery replacements. I mean, you got, we took a look at that M1 laptop that came out, and there's screws on the bottom now, which is really new, right? Like we're used to this kind of solid, smooth, extruded aluminum thing, but I don't think that phones are going to get more repairable necessarily, but I think what we've seen is there is such a big community and culture of people who want to repair a touch screen or a TFT or replace the battery, and this is not an uncommon thing.
It's happening anyways.
And they're expensive.
Yeah, and so I think Apple's getting ahead of what would have been legislation. And if you think about it, there's so much electronics. We're at the point where there really is only one solution, and that's to start to repair stuff.
Yeah.
So I feel like, things go in a big cycle. I think when the maker movement was happening, people were into repair, and then it kind of went away because everything was like a sealed monolith. And now we're back to you know what? This stuff is it's good. People are going to hang on to these things for a while. We should allow them to repair it.
Yeah.
So, I think there were some folks dunking. They're like, I can't believe they're doing this. They never liked this before. Well, why don't you celebrate some of the progress that's happening, whether they wanted to do or not? It's happening. This is a good thing.
It's not a step backwards. So we'll see what they ship, but I think making it so people have, I think even having a marketplace to buy, original parts. I know people are still going to go to the third-party market for parts because of the pricing difference, but I think it is a good idea for them to have something available.
Yeah. So,
yeah.
We'll see how it goes. All right, we have over 2,582 guides, Lady Ada. What's on the big board of this week?
Okay, we had a lot of guides this week. Kattni's updated the Welcome to CircuitPython guide. Again, she's done a lot of work with it, added a page about learning Python, updated a lot of the examples and text to reflect the current reality of CircuitPython. I think we wrote this guide back in CircuitPython 2, and now we're up to 7. So lots changed, lots updated. So it's great. Noah and Pedro did this very elegant NeoPixel ring lamp. We have a video that goes with that on 3D Hangouts segment, so stay tuned to watch that video. Liz Clark did an awesome RGB matrix dreidel game. She originally wanted to just have it play the dreidel song and have the animation. I said, okay, let's make it so that the animation starts when you put a coin in the slot, so you can collect the chocolate coins and then it dumps them out. So I thought that would be a funny project, and she actually did it with 3D printed parts, and I think it came out really great. We also did some Melissa did updates to the CircuitPython on Linux and Raspberry Pi guide, particularly for people who want to add extra SPI and I2C ports and how to address them. The way Linux addresses, at Linux and Blinka, it works, but if you want to do something that's not default, sometimes you do something a little bit extra. And then we've got an awesome contributor project, a color sensor-driven NeoPixel dress. It's a really beautiful an elegant and pretty complicated advanced project for wearables. So if you want like a more in-depth project with sewing and NeoPixels, check out this guide.
Okay, and then we have a bunch of, you saw the PyLeap stuff. I do want to point out something that was kind of neat. 560 in the chat said, PyLeap is magic. A friend stopped by my home lab a few days ago to solder a thing, gave a live demo of the beta, and they freaked out with joy when they sent rainbows to a thing with a button. Whoa. And that's how easy it is.
All about rainbows.
So we have a bunch of these. These are miniature guides that they're single serving. It's just to quickly look at the all the things you can do on your device. And if you're like, I just want to send a rainbow, it's that fast.
Yeah, I love this, the graphics treatment you got there too. Oh, are we?
All counting. Good work counting.
Latte's about now. But yeah, we got 7 guides for PyLeap with the embedded code in it. And what we're trying to do is have everything work together with like the BLE and the coding and the Learn guide and updated code that is pulled from GitHub. So there's actually a lot of architecture behind the scene to make this all happen, which I think is kind of neat and cool. Stuff like the library bundler is also part of this. Like everybody contributes code and then it comes together into like one big project. There's also from Melissa a guide on using the web version. So PyLeap is an app version, which is kind of more advanced. But if you just want to connect to the REPL and upload code to your CircuitPython board that has BLE, so nRF52840 boards right now, we have a Chrome-based web Bluetooth code editor. And yeah, it's totally wireless, and you can upload files and download files and libraries and upload code and run it and check the REPL. It also runs on mobile devices. I think Android has web Bluetooth support. iOS does not. So for iOS, you would use PyLeap. But we'll have more guides about all this because we're kind of approaching the wireless programming problem, but like 3 different ways. We're going to see what people prefer.
All right. It's now time to take a trip through space and time to Made in New York City factory footage. And it wouldn't be New York City factory footage unless you saw the latest. Boy, is this Disney headquarters across the street getting big. There's lots of welding. It's really noisy. What it lacks in stories, it makes up in noise. And then here's a beautiful autumn fall day outside the back window. This is our view here. This is New York City. It's not for everybody, but it's for us. And that's Made in New York City factory footage. 3D printing. Noah and Pedro are printing up a storm. We've got 2 videos. We can play them back to back. One is a project they built, a cool lamp, and the other one is speed up. Take it away.
Hey, what's up folks? In this project, we're making an LED lamp with NeoPixels. This uses several NeoPixel rings to make a modern style looking lamp. We designed and 3D printed a single piece to hold the LED rings in place with snap-fit diffusers. They're grouped together and arranged to look like they're gravity defying. In total, this has 124 NeoPixel LEDs. It has one 60 NeoPixel ring, two 24s, and a 16 NeoPixel ring. To make the assembly modular, we used Pico Blade Molex cables so they can easily connect together. The 3D printed holder features slots on the back that allow the cables to pass through. We use the LED animation library for CircuitPython to create this animation sequence. It's easy to modify the parameters so you can customize the animations to fit the feel of your project. The animations are grouped together, and depending on the type, they can have their own speed settings and different colors. It's really the best way to get NeoPixel animations going in CircuitPython. You can get the parts to build this project, links are in the description. The 3D printed parts are printed using PLA without any supports, and they snap fit together. The 60 NeoPixel ring is 4 quarter-sized PCBs that are soldered together using lots of solder. Be sure to check out the Learn Guide for a full step-by-step tutorial on wiring up these NeoPixels. The rings are pressed into their specific spots with the wiring coming out of the slots. They're daisy-chained with the data flowing from the large ring at the bottom to the smallest ring at the top. The Pico Blade Molex cables are soldered to the pins on the back of the NeoPixel rings. The wiring is pressed in between the edges to keep the PCBs tightly fitted into the holder. The rings are oriented so the cables can be easily connected together. The remaining cable is soldered to the data pin and then voltage and ground. The Raspberry Pi Pico is pressed into the 3D printed case with the PCB facing the opening for the USB port. To secure the case to the ring assembly, we used machine screws to attach the top cover to the bottom of the ring holder. The remaining cables are threaded through the top cover and connected together. An additional base is fitted under the 3D printed case for added stability. The Raspberry Pi Pico can be powered by a 5-volt USB power supply using a USB battery bank or the wall outlet. An extension cable with a built-in switch can be used to make it easier to power it on and off. We hope this inspires you to try out CircuitPython for your Raspberry Pi Pico. Thanks for watching, and don't forget to subscribe for more projects from Adafruit.
Okay, and don't forget 3D Hangouts. They're doing one next week. And we're going to keep showing you how to make all this stuff and more. Let us take another journey through space and time. I'm going to just use this up today. Another journey through space and time to
It's your intellectual property.
I on NPI.
I on NPI.
This week, INPI is brought to you by DigiKey and Adafruit, and this week's INPI is from Johnson Electric. Lady Ada, what is this week's INPI?
Okay, so this week's INPI is from a new company, so welcome to the Ion NPI party. This is from Johnson Electric. It's a Hong Kong-based company that makes motors and other motion control devices, and they have these pretty cool, I call them pancake, although I think that there's probably some other name for them, but short solenoids.
Lady Ada calls it pancake. I'm going to call it pancake.
I don't know. Every time something is kind of like round and flat, you know, in electronics, you tend to call it pancake. So I'm going to call them pancake solenoids. So they make a range of different motor control devices. In fact, their history, which I'll talk about in a little bit, is pretty neat. They make, steppers and DC motors and other coils and piezo stuff. Motion control, when people talk about motion control, usually is something like a DC motor. And, the motor is, a lot of people have seen motors before. You apply AC or DC current, and it rotates. Like there's permanent and electromagnets inside, and it rotates round and round. And so you get rotational motion. And then you can convert that rotational motion with a rack and pinion. Here's a 3D print project that we did, which has eyes in it, but you don't have to have eyes on your rack and pinion.
Yes, you do.
But it helps, and this turns rotational motion to linear motion. This is a repetitive linear motion. There's also, if you have a stepper motor and a worm gear or a lead screw, you can turn it into linear motion. So this is from a CD-ROM or DVD player, and you can perform, fairly fast linear motion this way, and it's very precise, but it has a lot of force to it, but it isn't kind of like instantaneous. And for that kind of instantaneous motion between two set points, you would use something like a solenoid. So this is a push-pull solenoid that we stock in the shop, and basically you can see in the middle there's that blue section, and that's the coil, right? So there's a coil of copper of of a variety of gauges and number of turns, and the number of turns and the gauge of the coil wire is what determines the resistance and the power, and also the force by which the slug, which is that center bar, moves in. So when you apply current to the coil, thanks to Maxwell's equations, it forms an electromagnet, and the slug is pulled in towards the center of the coil. This is like a cool diagram showing the force, the electromagnetic force is strongest in the center. There's a moving slug. Sometimes it's captive. Sometimes there's a spring. So this is a push-pull. And as you can see on the left, there's a spring. So every solenoid works the same way. It always pulls the slug into the center of the coil. But then when the voltage and the current, the power is released, this particular solenoid has a spring that brings the slug back out, and the spring isn't as strong. So if you want it to perform a strike or move something, you're going to get the most force on activation, not on the release, unless you have a very strong spring. But most people don't. So the solenoids that they make, if you compare to the previous solenoids we showed, those are all rectangular, and those are kind of the standard ones. They're like candy bar shaped solenoids. There's a coil, and there's a rectangular frame. These are interesting because they're much flatter, so they're easier to tuck into an area because they do have a big coil, but the coil is kind of, instead of like long and thin, it's wide and flat, like a pancake. And so they make a variety of different solenoids, and I'll show you the size range is quite extreme. I ordered two, and I didn't even realize how different. I mean, I looked at the photos, but until you have it in your hand, you don't realize how much different the sizes are. But the good news is that there's step models for each solenoid. So if you want to use it in your mechanical design, and none of these come with springs, so the return spring. Usually that's built into your design. Usually the frame is what has that return force, and so it's not built into the solenoid on purpose. Do check the spec sheet for each one. There's, I think, 12 volt and 24 volt, and there might be maybe a 36 or 48 volt one as well, although I definitely bought 12 volt ones because that's what I like to use the most, because I have 12 volt power supplies. Usually people use whatever power supply they need. I will say these use a lot of current, right? Solenoids are high current devices, so we're talking about a couple amps a piece easily. Depending on the size. And so, be aware of that. You don't need a very clean power supply, but you do need a lot of current. And solenoids don't, or at least these, I didn't see any that are latching type. So basically, as long as it's activated, as that slug is pulled in, you're drawing a lot of current. So when you spec it, do pay attention to the sizes and current requirements, the voltage requirements, and they have a wide range. Another thing that was kind of interesting is, I always go to the YouTube channel of the company to see if they have any videos demonstrating or showing off the capabilities of the NPI that we've chosen. And while I didn't find any solenoid videos, I found some other motor videos. I did find a really cool series in the Johnson Electric YouTube channel called like Chats with Old Timers. And
Yeah, it's like a documentary.
it's
cool.
kind of neat because they just found like, you know, these women and men who've been working at the Johnson Electric factories in Hong Kong since like, you know, 1970s, 60s, when the company was formed. And, you know, they had really cool old photos and stories about what it was like. And, you know, this is one of the first companies to make motors in Hong Kong. And at the time, you know, now, of course, we think of China and Hong Kong as major electric manufacturing and export companies. But at the time, you know, they were making toys, but they were not making the electronic components. Those were being imported, in this case from Japan. And so, you know, this company, Johnson, you know, they decided they wanted to try making motors themselves. And I guess they used to do garment as well. Another thing is interesting is the name Johnson. You'd think that perhaps the name of the company came from a guy named Johnson, but it's actually not. It's a transliteration of, I guess, like a Cantonese phrase that means all the quality that you can fit in every inch of a product. Like
Whoa.
it's a transliteration, like which is backwards, right? Like usually, like we have Coca-Cola, and then when it gets transliterated into like another language, they kind of try to make it fit to have some
We
meaning.
have a little bit of that video, a minute of it. You want to play it?
Yeah, we'll play. All right, we'll play that at the end,
play
or we
it
can
at the
play it
end.
now.
Yeah, let's play it now.
Okay.
And then we're gonna.
I forgot that I included the video.
Yeah, and then we'll come in for the big conclusion.
Okay.
So here you go.
The name Johnson, in Chinese, it is called 周全. 周 means the construction, the best construction. 全 means inch. Every inch of work means every stitch of work.
And my dad later told me why he picked the motor is because he believed the little motor will be something which is going to be there forever in a way, that affect people's lives, that you will use it in many, many appliances.
I think it was a genius decision. I'm thankful for it every day. Motion systems, electric motors, is affording us way more opportunities, like I just said, than potentially being, you know, a garment, for example.
You know, it was difficult years in the beginning. We are the first one in Hong Kong to make the motors. Before that, you know, the toy factories in Hong Kong are all importing expensive motors from overseas.
I don't think my dad understood how it worked. Being contrarian, if you don't have a local customer, find one overseas. If you don't have technology local, go to the place with the technology. So in a way, this is what happened to Johnson.
All right, we're back.
Okay, so I basically told the story of this company, but then the video. But do go and watch the two videos, because I watched them and they were like, even though I didn't know anything about this company, they were really well made and awesome videos. And it was really neat to listen to folks talk about the history of Hong Kong and manufacturing, because it's honestly not that different than the story of New York manufacturing.
Yeah.
So I thought there was a little bit of a reminder of the radio industry here in New York. Okay, so anyways, about these solenoids. There's a lot of different solenoids. I took a quick screenshot. There's just a lot of different ones, and they're all in stock. I just picked one that I thought was, you know, pretty cool. It's a chonker, and I'll show it off. They're just massive. This one has a 3D model view.
It's available on DigiCade.
It's available on
That is a
DigiCade.
chunk. Let's go to the overhead.
Yeah.
Chonk.
So I will warn you, this big one, which is the one I picked, it'll mess you up if you're not careful.
Yeah?
So I'm just going to show, like, this is the motor, and I've got this 12 volt, and you'll see how incredibly strong it is. Hold on.
Kind of scared.
It is a little scary.
Really?
Yeah. Okay, ready?
Yeah. Whoa.
Yeah. Like, it'll actually,
That wants
like,
to hurt you.
it'll mess up your finger.
Whoa.
Yeah.
Yeah. Okay. Let's put that away.
We're going to put this away. And we're going to bring out its small friend.
Hey.
Hi, little buddy.
Hey, buddy.
So this is the mini one.
All right. Don't feed that one too much.
No, this guy, I know. This is a little baby. But this shows. So yeah, when it's and you know it's still quite strong. Like
Yeah.
I
Yeah, that
can't quite.
Yeah, that can pinch you though.
Yeah, do be careful.
Yeah.
But this is the slug, and so
Yeah.
yeah, I don't want to be careful.
Yeah.
Here, I'll release it,
Yeah. Okay.
and then you can. There's a little ring there.
Yeah.
But
Whew,
I'll
okay.
do this again.
Most dangerous ion MPI yet.
Yeah, and so normally you would have a spring on the back, like maybe some rubber or like a metal that will push it back out. And each one, do check the data sheet for the stroke. Like it doesn't work if you have it too far out. Like it does have to be, you know, partially.
You have to make sure it's the right.
There you go.
Yeah, bump.
It's partially
Okay.
amount. Okay, so little mini solenoid and big chunker solenoid. So do watch out for your fingers with this one. But for the strength you're getting with this solenoid, it is not a very deep one. I mean, this isn't actually much deeper than the solenoids that we stock, but it's like much more likely to crush you in a good
And
way.
that's this week's ion MPI.
on MPI.
All right, so let's do the code. It is Neo Slider, 10% off in the Adafruit store all the way up till midnight-ish, because that's probably when I'm going to fall asleep, and that's when I will make the code expire. So let's go over new products. You ready, Lady A?
Okay, let's do new products, new products, new products, new products.
What's
Okay.
going on this week?
All right, let's kick it off with the new products. First up, we have a revision to the tricolor 2.9-inch e-ink feather wing, so you can plug any feather, including our new ESP32 S2 feathers, they're tested, onto the back of this feather wing. The update is, basically every e-ink display has been updated to use a different chipset. So it's the same resolution, same red, black, and white pixels. But instead of, I think, the ILI 0373 chipset, it now has the SSD 1675. I've noticed that pretty much everything is moving to the SSD 1675 and 1680 chipset with e-ink, but thankfully we've got driver code for it. So if you have an older project, you'll just need to select the different driver. Our library, you just tell it it's a different number, but other than that, the code and functionality is the same.
Okay, next up. This is Electrify. It's an Optimus playbook for our clean energy future. It's by Saul Griffith. We've known Saul forever. You were at MIT.
I went to school with him.
That's right. And I'm going to play a 3-minute interview with him, and this is from another website. I'm sure it's okay. It's his interview. And we're going to be stocking this book. We'll probably do some interviews with Saul and more. And basically, I know we're all trying to do a good job with saving the planet, but, not having a plastic straw is probably not going to solve it. There's some really big challenges ahead. And it's probably going to be solved with people like you out there and people who are building things and engineers. And I don't think anyone who's reasonable thinks that we should just be in a cave in a burlap sack. We probably have to build some solutions, and we probably have to work together. And so out of all the climate crisis things, I really like the idea of an optimistic view of something we can do with a big timeline and realistic things that you can do that have an impact, as opposed to just shaming everyone for, you didn't bring the tote bag today.
Which doesn't work long term anyways, because then people are like, what's the point? And if nothing I do makes a difference.
Yeah.
So I do think it's a smart, it's an engineer's view, it's a rationalist view. And he backs it up with the math. One thing I really do like about Saul is he's not just making shit up, he's not pulling stuff out and just reading random articles. He actually goes and reads the data, does the analysis, and says, no, this is really what's going to work for us, not just pipe dreams.
Yeah, we decided a long time ago, let's not take planes. No one Adafruit drives in. Our carbon footprint is probably as low as you can get. We live in a big city. We don't go on planes. And for a founder,
not having a car, we don't ever have a car. We're almost basically never in cars. We walk everywhere, and we don't take planes, and that helps a lot.
And one of the impacts that we have is
I'll read this book.
normally a founder of a company like you is constantly flying, and you don't.
Got a boat.
You don't.
Don't get a
And
boat.
so, anyways, here's an interview with Saul. It's 3 minutes, but I think it's worth it. Take a look at it.
Sadly, people have the impression that we can't fix climate and still have the American dream. That's not true. The reality is, we only need half as much energy as we think, and we don't have to shrink our cars, we don't have to shrink our homes to achieve that. Right now, you think that sounds too good to be true, but here's how you make it true. we need to electrify nearly everything. In 2018, I worked with the Department of Energy to map the entire US energy system, where energy comes from and where it goes. Everything from how much energy your toaster uses to how much energy it takes to make steel. It is really amazing just how much energy is wasted. The wasted energy we're talking about isn't really the wasted energy of forgetting to turn your kitchen light off. It's in the way we make and produce energy. More than 60% of the fuels that we use to generate our electricity get wasted as heat. More than 80% of the energy we stick into our cars in the form of gasoline or diesel is also wasted. If we electrify everything, we eliminate a huge amount of the waste. We don't need to shrink our cars, we don't need to turn the thermostat down, and we use less than half of the energy we currently do. We've got to electrify our trucks and our cars, we've got to electrify our homes, our furnaces, our hot water heaters, even the way we cook. And then we need to supply that electricity with our clean, non-wasteful sources, with wind, with solar, with hydro, and with other clean energy systems. And if we did that, we're going to save every business and every home money. Wind and solar are the cheapest forms of electricity going onto the grid today. Solar on your roof can be the cheapest energy source that we have ever had. If we use all of this cheap energy, there's an opportunity here for us all to save money while improving our energy systems. Think about that for a second. The future can be awesome. We can have cleaner water, we can have cleaner air, we can have cleaner skies and a better environment. And we can save thousands of dollars per year in every household. Why do I know America can do this? It's because America, uniquely in the world, has a history of taking on audacious projects. Solving the Great Depression, fighting World War II and winning it for the Allies, launching man into outer space. If America goes bold and big in that manner, and we do it focused on electrification of the economy, we can be the first country in the world to truly address climate change at scale and on the time frame we need. America is blessed with incredible resources and can easily run on clean and renewable electricity. America can be electric. Our future can be electric. Let's rewire America.
All right, so more ahead. That book will be in stock soon. Next up, this is one of the products that I've actually wanted to make many years ago, and I just couldn't get the support, and I'm so glad to see it. It's Browndages. So Band-Aids, they say skin-colored Band-Aids, but not everyone has skin that's the same color as a Band-Aid, but with Browndages, you can. And so we have these at Adafruit. We stock them. We love them. And I was thinking, you know what? Every maker accidentally cuts himself and has a little injury.
I burned myself. Actually, I have
and not everyone has the same skin tone. And so this is a pretty obvious, amazing thing. It's by a couple. It's a small business. We're so happy to support them. And we now, or we will have them in the Adafruit store. So you want to show these on the overhead?
Yeah. Okay, this is the packaging. So I think these, I'm not that good with tones, and I believe these are the four tones.
This is the assorted pack, so you can see. And then the way to really look at this is because of, here's our team here.
I'll say that the tones, this camera may not be good at replicating the tones, but there's 4 tones. Yeah, here you go.
Are you saying some digital cameras might not be tuned to all the variety of skin tones?
No, these two look the same, but in person they're not. So you get 4 different tone colors, 20 bandages, I think so 5 of each.
Yeah.
All the same size, and so I think we stock these because, like you can see, I cut myself. Oh no, I burned myself on the soldering iron. But if you're going to wear a bandage and don't want it to be visible as much, you can pick one to your skin tone. So it's kind of handy.
Yep.
I like it.
Next up, Lady Ada.
Okay, we got some more NeoPixels coming your way. People really like the NeoPixel dots, and they also really like which have kind of like a weatherproof casing and wiring, and then people really like the kind of the fairy light versions of the NeoPixels. And this one it's kind of in the middle. I know people are like, you guys have so many NeoPixels constantly, but this is different. So maybe on the overhead I can show what this is going on here. So this has a little mini NeoPixel here, and these wires, you can see they're coated with PVC, so they are not bare wires, so they have a little bit more weatherproofness resistance. Now, they're not rated for like dunking underwater, but this is epoxied and this is PVC coated, so these are much more durable than what I would say most NeoPixel strands are like, and they're much smaller than the dots. So they've got a nice small look, and as you saw, like they glow quite nicely through this kind of milky epoxy. And you just treat them just like everyday NeoPixels. Have it wired up to this Metro, and then, hold on, I can get my power supply.
Oh yeah? All right, I'm going to show this while we plug things in over here.
There's USB-C.
Yeah, you got one.
There's the
You got
micro B.
another one?
Yeah, there you go.
Okay, let's do this. Boop.
It's not working. Oh well. But live demo. So check out the animated video instead.
I'm just going to stick with this.
Stick with-
Okay, next
okay.
up, we got a bunch of these.
Okay, so Espressif has sent us 3 different dev boards, and they all look pretty much identical. So I'm going to explain the difference.
That looks like that.
They all have basically the
looks like
same shape and size. They let's go just look at maybe
one.
go to 2 more pics.
This one?
Yeah. They basically have an ESP32 S3 module on the left of the PCB antenna. The S3 is the next generation after the S2. The S3 has native USB. That's why you see 2 USB ports on the right. One is a USB to UART converter for like the debug port, and then one is the native USB that, if you're loading CircuitPython on it or Arduino, that's what will show up as, like mass storage, or if you want it to act like a keyboard or mouse or MIDI device. There's a NeoPixel in the middle, there's a power supply, there's a USB UART converter kind of middle right, and then there's the boot reset button. I like this dev board because it's exactly what you want and no more. So the S3 is a very new chip right now. As of this video, it's only supported by the Espressif IDF. It's not yet supported by Arduino, although I do see that they're doing commits. It's coming. So hopefully, if this is 2 months after this video's out, it should have Arduino support. It's not hard. It's just that there's a lot going on with the Arduino core, and I know they're working hard on it. MicroPython also, I think, has some preliminary support for the S3, and of course, CircuitPython. We're also working on the S3 as well. And having these dev boards out there is going to really help, because before then, you only could get raw chip samples, and people were like, I don't want to solder them. So there's 3 versions. There's a version with the Waroom module, as shown here.
Okay.
There's a version with the mini module, as shown here. And there's one with the Waroom module that also has 2 megabytes of PS RAM. All of them have 8 megabytes of flash.
Right.
They all look pretty much the same. The mini and the Waroom, I'll be honest, I don't really know the difference between them, other than maybe there's some thermal consequences, or maybe the antenna is slightly different sized. But those are fairly much the same. The one with 2 megabytes of PS RAM, if you're using, you need a lot of RAM. If you're using MicroPython or CircuitPython, I would definitely recommend going with the PS RAM version, because that 2 megabytes really helps when you want to load a lot of code, or you want to grab a big JSON file from the internet and parse it. The S3 has Bluetooth low energy support as well as Wi-Fi, compared to the S2, which only has Wi-Fi. Note that it doesn't have Bluetooth Classic support. The ESP32 non-S2, non-S3 had Classic. They've dropped Classic support. So it's only Bluetooth and low energy and Wi-Fi. There is some neural net acceleration, and there is 2 cores for the Tensilica 240 megahertz processor. So it's kind of a bump up from the S2, which is nice. I think the 2 cores are going to be really helpful. One core does Wi-Fi, and then the other core can do computation. And I think, of course, the BLE is awesome. It's always great to have a chip that can do Wi-Fi and BLE, because it means you can do both, LAN and WAN type stuff. So I can show.
You want to show it off on the overhead?
Yeah, I mean,
Let's show
I
it off on the
decapped this chip, which I thought could be fun. Sorry, I did not decap it.
All right.
Dano decapped it. Thank you, Dano.
That's cool.
So you can see this one, it has the flash built into it. and this one has the flash separately. Or it's the PSRAM. Can't quite tell from this photo. But then also I think what is really nice about this dev board, thank you, it now has 2 USB ports. The previous minimal dev boards only had 1, and it was like you had to wire up USB, but I like that it's 2 because you can connect one to your USB to serial converter for uploading code from one port, and then the USB separate, so you're not, sometimes computers don't like it when the USB port disappears, comes back, doesn't enumerate, blah, 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 so this kind of keeps it separated. And of course, you can always have debug data coming out the UART while you're writing your code, because you can't connect JTAG to it, but the UART is still kind of the premier way of doing debugging and
in
analysis.
the chat, 2 Core ESP just in time for the start of async age in CircuitPython.
It might be a good time. I'll say that
Yes.
async will, the way we're going to handle 2 cores in CircuitPython is not necessarily going to be with async, but we're going to do it in the right way. But that said, other Arduino, of course, will let you have access to both cores.
And tonight, the star of the show, besides you, Lady Ada, our team, our
Okay.
customers, our community, everyone here tonight,
Anybody else?
everyone who's interested in building a better future together. It's the Neo Slider.
Thank you. We're back. So we designed all these boards with the SAMD09. Can't get SAMD09. We designed them for the ATtiny 807, 817. Hopefully we'll be able to get plenty of those chips. So this is a I2C to slide potentiometer plus 4 NeoPixels board. And we also already had the rotary encoder to I2C. So this is kind of like a plug and play slide potentiometer that's kind of ready to go. It's panel mount friendly. It's got chainable STEM QT connectors. There's 4 address jumpers that you can cut. You don't even have to solder them. You cut them to set them, which I kind of thought would be a nice user improvement. And of course, there's 4 NeoPixels underneath. If you have a microcontroller that has analog inputs, maybe it's easier and cheaper for you to wire it up. But with these, you're going to get, it's already mounted on a board, ready to go. It's plug and play. We have Python code and CircuitPython code and Arduino code. And of course, if we want to use this with our USB to STEM QT adapter, it's a great way to add a slide potentiometer to your computer. Or for Raspberry Pi, which doesn't have analog inputs, but does have I2C, you can plug this in there. So I've got a quick demo showing from the top, and I've got this plugged into a STEM QT, and then there's a little microcontroller on the back, takes the I2C commands, converts them to NeoPixels, and can read the analog inputs. So this demo just changes the potentiometer value to the NeoPixels. You get kind of a cool backlit effect. I'll say that because if you're going with the through lit effect on the NeoPixels, because the PCB is orange, blues don't show up as well. So you get like a nice green effect, and orange, red, and purple. But blue ends up kind of being like, this is purple, it kind of filters out the blues a bit through the orange, and so you get more of a reddish color. So you can see that from the side. That said, you can connect a bunch of these up, add rotary encoders, add the Neo key, and they're all the same physical size. So sorry, the Neo key and this are the same physical size. It's 3" by 0.8 inches. You can use it as a breadboard, but I kind of like just plugging and playing it with STEM QT or Quick to add quick user interface elements. And this board comes fully assembled because we kind of we attach the potentiometer and put it through the selective solder machine. So it really is ready to go, whereas the rotary encoder board, it's kind of choose your own rotary encoder.
Okay, and that's new product. Okay, so what we're going to do is we're going to do some top secret. While we do that, I have some questions lined up. Thanks for letting me know, folks. But do put your questions in adafruit.it/discord, and we will get to them in just a second. Here's top secret. Got a couple things in top secret this week. First thing from the vault is we got tons of pink boards. Tom's Hardware did an article about the pink boards that we're doing. Lots of people done pink boards. We're doing pink boards. These are going to be super cool. So get ready. They're almost here. And then I'm going to show 2 videos back to back. One is our new feathers, and another one is a preview, which anyone can play with now on Whippersnapper. All right, Lady Ada, what is this?
Hey, I'm testing out the new prototype I made for the Feather ESP32 S2 with the S2 on the back. And on the top is the battery and USB and batteries buttons and a 240 by 135 color TFT. So the demo I'm doing here is showing off the number of GitHub stars within the CircuitPython repo. And if I can, so you can see the REPL appears on the TFT. So that's a good test. And then when I rerun it, you can see it's pretty fast. It only takes a few seconds to connect to the internet and make an SSL connection to GitHub and fetch the number of stars. So this is very similar to this project that we did with the PyPortal, but it's on a teeny screen. So maybe we can port some of our PyPortal projects over to this little all-in-one board, which is also battery powered. Very nice. Coming soon.
Lady Ada, what is this?
I'm testing out some new whippersnapper features. So this is a Funhouse board. It's an ESP32 S2, and it's got an AHT20 temperature and humidity sensor down here. And up here on Whippersnapper, this is the beta. So this is private, but will be released soon. If you go all the way to the right here, I can add a new component, and the new component is an HT20 sensor. And it does an I2C scan and detects the address. And then I can set it up to send data every 30 seconds. Create the component. And boom, I've got 2 new feeds with humidity and temperature data coming in automatically. No code I2C sensor data from your dev board to Adafruit IO.
And that is top secret. But you know what's not a secret? We're making things so easy. You're going to have so much time, you're going to have to figure out something else to be angry about. So let's do the questions. You ready?
All right, let's take a look.
So here we go. I got some lined up.
Okay.
We dive into the questions. Okay, so the first question is, question for Lady Ada, the latching relay Featherwing that JP shared on his last product of the week, Featherwing latching relay. Wondering what happens if you set both pins set unset high at the same time. Does one take priority?
I actually don't know. I think it is whichever one is last, or it could get stuck in the middle. I don't know. You can try it and get back to me. I've never done that.
Okay. Here's those links for the app. I put those in the chat.
Yeah.
You can join now. Hi, I have a question for the Adafruit libraries. Me and my team are trying to subscribe and publish to 2 feeds at the same time, and it worked yesterday, but does it work anymore? Thanks. I guess that must be Adafruit IO.
Well, it could be, any MQTT. I don't know if you can
They
turn
post in
on
the forums for that.
Yeah, post the debug log. I mean, I think that would be helpful. Or turn on the debug log and look at it. It might tell you what's going on with your feeds. I mean, it could be you're running out of memory or data or bandwidth, or you're rate limited. You have a typo maybe. Board support package might have changed in the meantime. Lots of stuff.
All right. Question for Lady Ada. I'm working on an external case to house my power supply and Ender 3 Pro 3D printer controller board. The power supply has a very loud fan. Is there anything wrong or bad good with removing the cover and fan for the power supply and using a separate fan for the overall housing? Will I damage my PSU?
It's tough. I mean, I think I would recommend, if you do replace the fan, you really do need to make sure you'll probably, there's probably some thermal protection. I mean, probably, I don't know for sure. There's probably thermal protection, so it'll shut down if it's not getting enough coolant. You're probably better off, if you can, replacing the fan with a more expensive ball bearing fan that is a lower noise than trying to design the case to get the same airflow if you're not 100% sure how to do it. So we actually have a great search on finding quiet fans for 3D printers, because somebody had a question about a 3D printer fan. So check that great search. It's like the great search, like fans or something, and use that, and you can pick up from DigiKey a matching fan that has a much lower decibel noise.
Is there a 5 gigahertz wireless microcontroller that can run CircuitPython?
I don't know of any 5 gigahertz Wi-Fi. Maybe the Amoeba maybe was 5 gigahertz. I think it was like a weird, like, whoa, that's unusual that it's 5 gigahertz. I think Espressif is working on 5 gigahertz, but it's a little rare.
Okay.
Look, even my computer doesn't have 5 gigahertz.
I can answer this one. Will the pink feather RP2040s be out in time for Christmas?
They're going to be out in time for Thanksgiving.
All right.
But there's a catch, and we'll tell you about the catch next week.
Really?
Yeah.
What's the catch? Oh, yeah. Okay, that's a good one. Yeah, tune in next week for that one.
Well, yeah, you didn't know the catch.
Yeah.
But
All
I knew the
right.
catch.
But yes, they will be. Okay, and with that is... Okay. Yeah, folks should put their questions in the Discord because that's where we can
Go
see
to
them.
the Discord,
Yeah.
folks. That's where we're at.
That's where we can manage it. So those are the questions from Discord, and I'm gonna wrap it up right here.
All right. You can have the green screen with a gigantic green question mark or something.
All right, everybody, that's our show for tonight. Someone said, now it is time where we dance. You know what I could do? Dun, 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 dun. We're not going to do that.
You do have a little bit of the, you have like, you have turtleneck
I don't
on.
wear turtlenecks because I feel like that's another category of folks in tech.
Yeah.
Not me.
You don't
I'm
wear
not
the
invited. I would never go to an event that would have me as a member. Okay, so that's our show for tonight. Special thanks to Cara, who's in the chats.
Thanks, Cara.
Also, here's some good news for I guess everybody. Takara and I are working on some writing stuff together, so you'll see some cool articles by us. That'll be happening very soon. Special thanks to everyone in the chat, in the community. Thank you so much for making this the best hour-ish of our week every single week. And then when we do show and tell, that's one of the best half an hours of our week every single week. We will be doing all of our shows. Next week, Lady Ada and I are doing volunteer work at a food bank. We are delivering some pies to a person who's in the hospital because
They wanted pies.
They want
Which I
pies for the
agree.
staff. Yeah.
Well, have a slice.
Yeah, and so we'll be doing our show on Wednesday, and then we'll be doing a lot of stuff. I'm doing shipping Friday, Saturday, Sunday with the team. And so it should be a big holiday. Please purchase something from Adafruit. That's how we keep all this going. Every little bit counts because times are tight. There's not a lot of chips and not a lot of stuff. And the last 18 months were the worst.
And we're
the
still
worst.
getting like 52 lead times.
We're crawling out of a hole, but thank you everyone for being that rope that's getting us out of it. We're getting out of there.
Yeah.
So that is it for this week. This has been an Adafruit production. Thank you so much. Here is your moment of Zener. Oh, someone said, don't forget the lunar eclipse Friday morning. Yeah, don't forget that.
If you're in the zone, I guess. I don't know.
Yeah, here's your moment of Zener.
Bye.
Thank you.